Okay, guys, hey, this is going to be your lesson 22. Sorry we had to go virtual today, but you can probably tell from the sound of my voice that it's for the best. Okay, so lesson 22, understanding solutions. So we're going to start by talking about concentration and solubility. So what's solubility? The ability of a solid, liquid, or gaseous chemical substance referred to as the solute to dissolve in, what do solutes dissolve in? Solvent, usually a liquid, but not always, and form a solution. Solubility is also a measure of how much solute can be dissolved in a solvent. The solubility of a substance depends on the solvent used, as well as temperature and pressure. These are going to be important. Now, if you look at our graphic here, you'll see an example of a solution there on the left, a suspension in the middle, and if you remember, we talked last week, a suspension has particles that are sufficiently large enough to settle to the bottom under gravity's force. And then there's a new vocab word for you here on the right. You guys know that if a chemical reaction occurs in solution and a solid forms, that solid is your precipitate, and we say it crashes out of solution, such a great term. But the part of the solution that remains that is not in solid form, that is in liquid form, we call that the supernatant. So there's a new word for you. Concentration. The amount of a substance in a defined space or volume. Concentration is also the ratio of solute in solution to either solvent or total solution. So this is important to understand. You can measure concentration in one of two ways. You can measure it as solvent to solute. Oh, I'm sorry, solute to solvent, or you can measure it as solute to total solution. So you can say I'm doing 50 grams of sodium chloride to 200 milliliters of water. You can make that ratio your concentration. Or you could say I'm doing 50 grams of sodium chloride to 50 grams of sodium chloride in 200 milliliters of water. It can be measured either way. The concentration of a solution is the quantity of a solute that is contained in particular quantity of solvent or solution. So if you look here, you could probably guess that your more concentrated solution is going to be the one on the left based on color. So if this was like dye in water or maybe cranberry juice that you've diluted, it looks like cranberry juice to me, you can definitely see that you've got more concentration on the left than on the right. So we talk about dilute solutions. A dilute solution contains only a small amount of solute in your solvent. But then opposingly, we have concentrated solutions. Concentrated solutions contain a lot of solute in their solvent. You can change the concentration of a solution by adding more solute or by removing solvent. So how do we do that? Okay, well, so to dilute a solution is pretty easy. You just add more solvent. If you have salt water and it's too salty, you add more water and it becomes less salty salt water. You have more dilute solution. So to dilute it, you add more solvent. But to concentrate it, you can add more solute. You could add more salt to your salt water, or you could remove some solvent. How do you remove the solvent? Well, one way to do it would be by heating it, which is what it's showing you over there on the left, where you have the little Erlenmeyer flask on that hot plate. If you heat it, you will vaporize, you'll boil and then vaporize some of the solvent, which is water, perhaps if we're talking about salt water here, and then that would further concentrate your solution. The same could be said for letting it evaporate. So what factors affect solubility? So solubility is affected by pressure, temperature, the solvent you're using, and the surface area of your solute. And we'll talk more about that in a bit. So now we have another gas law. Oh my goodness, we are swimming in gas laws, aren't we? This one is Henry's law, and it has to deal with pressure and gas solubility. So Henry's law states that at a constant temperature, the amount of a given gas that dissolves in a given type and volume of liquid is directly proportional to the partial pressure of that gas in equilibrium with that liquid. Blah, 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 blah. What does that mean? Pressure and gas solubility are directly proportional. The higher the pressure, the more solubility you have with your gas in your solution. The lower the pressure, the less solubility. This makes sense if you just think about opening a 2-liter bottle of soda, or even one of those little 16-ounce ones that you get out of the vending machine or out of a 6-pack of Coca-Cola or whatever. As soon as you twist the cap, the first thing you hear is that gas release, that shh, and that's because you have now reduced the pressure in that given volume of soda, that's that solution. And since that pressure reduced, some of that gas is now escaping. When you had it under higher pressure, more of that gas was dissolved in solution. Temperature and solid solubility. So we just talked about gas solubility and pressure. Now we're going to talk about temperature and solid solubility. Generally speaking, the greater the temperature, the greater the solubility of a solid. Temperature and solid solubility are directly proportional. So if you have hot water, you're going to be able to dissolve more sugar in it or more salt in it than if you have cold water. And we've done this in lab already. It was one of our earlier labs when we had the potassium chloride that we were dissolving potassium chloride and sodium chloride, and they had different measures of solubility for different temperatures. And now we have temperature and gas solubility. So this one may seem counterintuitive, but just it's one you just got kind of got to remember. So generally, the greater the temperature, the lower the solubility of a gas. So that means that temperature and gas solubility are inversely proportional. The colder your solution, the more gas you can dissolve. The warmer your solution, the less gas you can dissolve. This will come into play in earth science when we talk about atmospheric CO2 and ocean temperatures. When ocean temperatures rise, you will have greater atmospheric CO2, meaning that your greenhouse gas levels will raise when your ocean temperatures rise. So keep that in mind because that's something that does come into play when we discuss those topics in earth science. We will bring it right back around full circle to this conversation right here. Okay, solvents. How does solvent affect solubility? Okay, like dissolves like. That's something to remember and memorize. Like dissolves like. What do I mean by that? Polar substances dissolve polar substances. That means polar substances such as polar molecules can dissolve ionic compounds. Remember last week there was a little like a cartoon in the slideshow that said something about polar bears dissolving in water? There you go. Nonpolar substances dissolve nonpolar molecules. Nonpolar molecules and organic compounds are soluble. So like dissolves like. Commit that one to memory. All right, so let's talk about surface area. Okay, the greater the surface area, it's good. The greater surface area speeds up the dissolving process. So that means that surface area and solid solubility are directly proportional. So think about it this way. If you had the same mass of sucrose in a candy cane and in granular sugar form, like table sugar, okay, and you put it in a glass of water, which is going to dissolve first, the granulated sugar or the candy cane? Obviously the granulated sugar. Why? Because each little unit of sugar that's in there has greater surface area because it's down to a little crystals, little sugar cubes, little tiny crystals. They are cubes if you look at them. They're not these big cubes, but they're itty bitty ones. All those little granular ones look like little cubes. But that means they come in contact with the solvent more. And since more of the solute is coming in contact with the solvent, it's going to dissolve more rapidly than if it were not so. So now let's talk about saturation. Saturation, what is that? So an unsaturated solution contains less than the maximum amount of solute that is capable of being dissolved. So this could mean something is dilute, but it doesn't necessarily have to mean it. It just means it's less than what the solution is capable of dissolving. Then you have saturated, which means the maximum amount of solvent has been dissolved. Any more solute added will sit as crystals at the bottom of the container. And then you have supersaturated, which contains more than the maximum amount of solute that's capable of being dissolved at a given temperature. How can you have more than the maximum? Well, that means at some point during the process of forming this solution, you altered something. And here's what matters: temperature. You altered the temperature. So a supersaturated solution is one that has typically been heated, which allows for more of the solute to be dissolved in the solvent, and then cooled. And once it's cooled, now it's holding more than it should be able to hold at that temperature. So you can try this at home. It's not difficult to do. You can get you a small volume, like maybe 8 ounces of water, and get some salt or some sugar, probably sugar, because you probably have more sugar at your house than you do salt, just by mass. And you can try taking that 8 ounces of water in a measuring cup and add a little sugar to it, and you've got you an unsaturated solution. And keep adding it and stirring until you get to the point where you can't add any more without there being sugar crystals at the bottom. Now your solution is saturated. And next, what you want to do is go ahead and take your solution and heat it up. You can microwave it, or you can take that measuring cup of water and pour it into a pan and heat it up on the stove. And when it gets nice and hot, you add even more sugar to it and then let it cool back down. And then you should see some crystals form. That's how they make, like, rock candy and stuff like that. All right, so solubility. Let's watch a quick video on solubility. If it'll play, please play. There we go.
Welcome back to the Science Basement. In this video, we're going to explore solubility. At the start, it's important to define a few key terms so that we can understand how to talk about solubility. The first is, of course, solubility itself. The easiest way to define solubility is that it's the ability of a substance to dissolve in another and form a solution. If we look at that more closely, you'll see that solubility is basically a combination of those words, solution and ability. So we get solubility. Next, we have solvent. A solvent is the substance that does the dissolving. In the case of hot chocolate, for example, the solvent would be the water. And lastly, we have solute, which is the substance that gets dissolved. In our previous example of hot chocolate, the hot chocolate mix would be the solute. Overall, water is a great example to use when talking about solubility in dissolving substances, and is one that we're likely most familiar with. But what actually happens when we dissolve something in water? Let's look at salt as an example. If you pour salt into water and stir it, you would notice that the salt fairly quickly disappears. We know it's still there though, because if we were to taste the water, it would be salty. Let's take a closer look at what goes on when we dissolve salt in water. Water is a molecule made of 2 hydrogen and 1 oxygen atoms, hence the name H2O. Water has a pretty unique molecular structure, and to me it reminds me of a head with 2 ears on top. One of the things that happens because of this molecular structure is that water naturally develops a small polar charge, kind of like a magnet, with the hydrogen side becoming more positive and the oxygen side becoming more negative. Water becomes polar because the electrons that are shared between the hydrogen and oxygen as part of their covalent bonds tend to be hogged by the bigger and stronger oxygen atom. Because electrons carry a negative charge, that means the oxygen side of the molecule becomes slightly more negative and the hydrogen side becomes slightly more positive. Because water is a polar molecule, it's able to dissolve other polar substances such as ions and other polar molecules like itself. Water is so effective at dissolving many different things that it is often referred to as a universal solvent, but it's not truly universal because there are some things that can't dissolve in water, like oil, for example. Now back to our example of water dissolving table salt. If we were to look closely at a cup of water, we would see the water molecules moving around freely. When we put a salt crystal into the water will act as a solvent and the salt as the solute. The water molecules will start to pull the sodium and chloride ions off, with the positive side of the water molecule removing the negatively charged chloride ion, and the negative side of the water molecule attaching to the positively charged sodium ion. The sodium and chloride ions will dissociate until they're completely dissolved, meaning that each individual atom has been removed and has formed a perfectly mixed solution with water. This is key to what dissolving is. That is, each individual molecule or ion is surrounded by water. If that doesn't happen at the molecular or atomic level, then that substance doesn't truly dissolve in water, but may just form a suspension, like if we were to mix flour and water, or a colloid like milk and water. They mix with the water, but if you were to look closely, you'd see larger particles floating around, not individual molecules or ions. The reason why certain things like oil are not soluble in water is because they don't have positive or negative charges for the water molecules to interact with. When this happens, that substance is said to be insoluble in water. The ability of solutes to dissolve in solvents is critical to life on Earth. If we break it down, you can see why. Let's start with our bodies, for example. Our bodies are about 60% water, and we use solubility for many processes. For example, our digestive systems carry nutrients into our bloodstream and throughout our body with water, then use water to remove waste. Plants need water not only for the photosynthesis process, but to transport dissolved nutrients to the roots, into the plants, and throughout their tissues. Liquids aren't the only things that can dissolve other substances. Every time we breathe, we are breathing in a solution of gases that are dissolved in each other. These gases are about 78% nitrogen, 21% oxygen, and about 0.04% carbon dioxide, or the composition of the atmosphere. Solubility is an amazing scientific principle and can be easily tested at home or in the classroom. Gather up some common ingredients like salt, sugar, flour, baking soda, cornstarch, or others, and mix them with water and observe what happens. Which ones dissolve and which ones don't. See if you can figure out why or why not, and leave your observations in the comments below. And of course, if you like this video, make sure to give it a like and subscribe to the channel to be notified of future content. Thanks for tuning into the Science Basement.
You'll notice that he mentioned testing cornstarch and flour and seeing whether or not they're soluble in water. You probably know that they're not. They're not going to dissolve, right? They'll make like a suspension situation. Well, that's because they're organic compounds. Those are starches. So if you remember back, we had the slide just a little bit ago. I said like dissolves like, and it said nonpolar organic compounds. So you've got organic compounds there that are not going to dissolve in water. Okay, let's see. Although some do, because sugar is an organic compound, but still, in general. Okay, what amounts do you compare when measuring concentration? Your answer here should be solute to total solution and or solute to solvent. Because remember I said you can say your mass of salt to your volume of water or your mass of salt to your volume of salt water. How can you tell that a white powder is salt without tasting it? Well, there's lots of things, but your book answer suggested that you could measure its solubility and compare it to known levels, which seems like a lot of work. Which solution will have more gas dissolved in it? A solution under high pressure or one under low pressure? A solution under high pressure will have more dissolved gas because that's Henry's law. If you've ever used one of those cans um, it's like a duster can. It usually has like a little nozzle with like a straw that you stick on it and you use it to blow dust off of like electronics and things like that. That is gas under high pressure. And you can get a lot of gas that would typically spread out into a much larger volume packed into that little can if you put it under high pressure. Same thing with like a fire extinguisher. There are solids in there, but there's a lot of gas under high pressure. Or a hairspray can, any kind of aerosol, same idea. How does temperature affect the solubility of most solids? The greater the temperature, the greater the solubility, generally speaking. A dilute solution is a solution that has only a little solute. A concentrated solution is a solution that has a lot of solute. Solubility is a measure of how much solute can dissolve in a solvent at a given temperature. And a saturated solution is a solution that has so much solute that no more can dissolve. What's the difference between concentration and solubility? In chemistry, concentration refers to the actual amount of solute dissolved in a given amount of solvent at a specific time, when solubility refers to the maximum amount of solute that can dissolve in a given amount of solvent under specific conditions, essentially acting as a limit to how much solute can be dissolved, meaning concentration can never exceed the solubility of a substance in a given solvent at a given temperature and pressure. So that last part, concentration can never exceed the solubility of a substance in a given solvent at a given temperature and pressure. How can each be changed? Concentration and solubility can be changed primarily by altering the temperature and pressure, especially for gases, and nature of the solvent, as these factors affect how much solute can dissolve in a given amount of solvent. Essentially, by manipulating the interactions between the solute and the solvent molecules at a molecular level. So, if you want to make something more dilute, you can add more solvent. If you want to make something more concentrated, you can remove some solvent or add more solute. You can also change the amount of pressure or the temperature that are acting on the solution, and those are all things you can do to manipulate the solubility of a given substance, a given solute in a given solvent. Okay, so there you go. Now for lab, what you're going to need to do is you're going to need to go to the lab assignment in Teacheries, and you're going to want to watch the video from the last time I taught chemistry 4 years ago. I actually have a video for this lab, so you're going to watch the video, get together with your lab team, and one person on your team, most likely your captain, will hand in the digital file upload for the whole team. Although you have your assignment will appear as if you need to upload something, you don't. Only one person does, probably your captain. What I will do is I will then distribute that same upload amongst everybody else's gradebook account. So you will have that in yours as well, once I get it from your captain. And then that's how you will complete your lab for this week. To get credit for this, go ahead and comment that you watched it uh, in the YouTube. I'm sorry, comment in YouTube telling me that you watched this. Sorry, I'm a little out of it today, guys, but I'm doing my best. Thanks for bearing with me, and I'll see you next week.